Basically, but the question is demanding you that you have given some interval x of n minus 1 comma x of n plus 1. So if I make it like this, it is x minus 1, 6x of n plus 1, and it is somewhere xn. So it is saying that f has a minimum in this interval. Okay. So what we can do, we can first interpolate f in x of n minus 1 comma x of n plus 1. And that will be a polynomial of degree 2, right? Fine. So what I'm saying is, if I interpolate my function f in this interval x of n minus 1 up to x of n plus 1, okay, and then both of and I get a function say p, okay, so that p of x of I is equal to f of x of I 1 less than equal to I less than equal to sorry, n minus 1 and plus 1. So basically at 3 points we are evaluating the points, and then from there I will get some polynomial p of degree 2. Okay. After that, what it is saying that show that the interpolation of fx in this interval, which is nothing but our p of x, by polynomial of second degree yields the approximation for the minimum value of fx. So basically, what do we need to do? First of all, we will find our px. What is that? And we will find p prime x. Zero. What we do? We find the derivative and put it equal to 0 and find the critical points and find the critical points. So p prime x of a star is 0. Okay, so you can check that p double prime of x star should be basically less than 0 to have minimum. Sorry, it should be greater than 0 minimum, right? If this is the case, then I can find p of x star. So this will be a minimum value of p in this interval, right? So what we are doing here, we are just till now we are just doing writing what are the assumptions are given, that f has a minimum in the interval. So what are they asking? Interpolate the polynomial in the defined interval and find the point of minimum. So we did the same. We will find the polynomial of degree 2, right? And then we will put the derivative of the polynomial to be 0. So in order to get the critical point, and we will evaluate our function p at that critical point. Is this making sense?
Yes, sir.
Okay. So let me do some basic calculation here. So we know that p of x will be nothing but f of xn minus 1 plus x minus x of n minus 1 equation f of x of n minus 1 plus x minus x of n minus 1 x minus x of n minus 2, sorry, x of x minus xn plus f of x of n minus 1. Fine. This is what our px is. So evaluate p prime x. It will be Laplacian f x of n minus 1 plus 2x minus xn minus x of n minus 1 Laplacian square f of x of n minus 1, right? Okay, just a second. Are they given something? Okay, it is also okay. At the end of the day, I want my result to be f of n plus 1, f of n minus 1. So let me write in that notation only. You know that Laplacian f of n minus 1 is nothing but f of xn minus f of xn minus 1 on xn minus x of n minus 1. Nothing but f of xn minus f of xn minus 1 upon h. And similarly, Laplacian square f of x of n minus 1 will be f of x of n plus 1 minus 2 times f of xn minus plus f of x of n minus 1 upon 2s square, right? Are we good till here?
Yes, sir.
This is the notations we use, right, in Newton's interpolation. And without loss of generality, let me use a new notation now. Laplacian f x of n minus 1. I am just writing it to be the error, okay? F of xn minus x of n minus 1. Just to make myself clear that and Laplace square f of x of n minus 1 to be f of xn, which will be nothing but f of x of n plus 1 minus 2 times f of xn plus f of x of n minus 1. I am doing that so that I can get myself in terms of h, and instead of writing all of these f of xn plus 1 and so on, I should write this notation. You can use any notation. So please do not confuse. Okay, let me use delta. Okay, so basically my p prime of x is nothing but delta f of x of n minus 1 plus 2x, okay, delta upon h, right, minus xn minus x of n minus 1 upon 2h square delta square f of x of n minus 1. Does this work fine? So basically, if I substitute p prime x to be 0, I will get my x to be, if you see, xn plus x of n minus 1 upon 2 minus h times delta square f of x of n minus 1 upon delta f of x of n minus 1. Okay, so let me put it x minimum. Now you can just find px min. You have your p, have your x min, just substitute it. So you will get fx of n minus 1 plus xn minus x of n minus 1 minus times of plus h time of f of xn minus 1 upon delta square f of x minus 1 into 1 upon h into delta f of x of n minus 1 plus and so on, right? Are we good till here? Are we good till here?
Yes, sir.
So can we proceed with the calculations now? Because you already have px, that is what you were asked to. And similarly, you just substitute it here also. So let me write that also. It will take a couple of seconds. Minus x times delta f of x. Sorry. What should I put this? We have to substitute it here now. X minus x of n minus 1 and x minus xn. Right? So substitute value of x, this value in star, and using hash. So basically substitute value of x min in star and using hash. Okay. So after that, everything will be just calculation. So you want me to do the calculations, or you just want to have the idea, okay, what is happening, how it is happening? Because if you just want the idea of the problem, then this is the idea, and after that you just need to do the calculation part. But if you did faced some issue while doing the calculation, like if you have reached till this point and then you face difficulty in doing the calculation, then I can do the calculation also. It is not a big deal. So please let me know.
Sir, we will try after this.
Okay, so the thing was you didn't get the idea how to proceed the question. Is that so?
Yes, sir.
Okay. So after that, it is just a matter of calculation. Okay, the manipulation of things, and you can work it out. Okay.
Okay, sir.
And is there any other question you in the minor exam you want to discuss? I think more or less rest of them were already been discussed in the tutorials, by the way. But if you still want a discussion on any problem, please let me know. Shall we proceed to assignment sheet 6 then, if we don't have any doubt?
Yes, sir.
Hello.
Yes, sir.
So I assume that we are clear with minor.
Yes, sir.
Okay. So have you guys tried doing assignment sheet 6?
No, sir, we haven't tried.
Then it will be a difficulty, right? Okay, then let us try it here. We have 40 minutes. Please read question number one and tell me, is it doable? Okay, first of all, let me ask you midpoint rule and the composite ones, like composite trapezoidal, composite function. Do you guys have any doubt there in the theory?
No, sir.
Okay, then please read question number one and tell me whether it is doable or not. You have given some function fx, which is nothing but e to the power 2x dot sine 3x, and they are asking you to find the number of iterations n and the required h. See, if you have n, then you can easily find h, right? So now tell me, can you find n for the composite trapezoidal rule or composite Simpson rule? I think you guys must be having the error formula with you for all of these. We have fx to be e to the power 2 sine 3x, right? And you want to find such that error is less than 10 to the power minus 4. So error for episode composite is given by maximum mode of f double prime of x will value ab and b minus aq, right? This is the formula for the error. So now it can be doable, right? Because your a is equal to 0, b is equal to 2, fx is e to the power 2x sine 3x. So f prime x will be nothing but e to the power 2x, 2 sine 3x minus, sorry, plus 3 cos 3x, and f double prime x to be e to the power 2x minus 5 sine 3x plus 6 cos 3x. So just find the maximum of this in 0, 2. So basically, in order to find the maximum, you have to do one more derivative, right? So we have to find the maximum value of this function in this interval. Say it is m. Basically, what we want, m into 2 cube 0.12 n square should be less than 10 to the power minus 4 or 8 into 10 to the power 4 m should be less than upon 12 should be less than n square, right? And to find h, what do we need? B minus a upon n. Is this fine?
Yes, sir.
Okay. Do question number 2, please, and tell me the value of alpha then. That is 225. I don't think it should take more than 5 minutes. So, do question number 2 and tell me what is alpha.
So minus 1.125.
How much is it coming? Minus 1.125.
Yes, sir. So your voice is breaking.
Is it good now?
Yes,
Hello.
sir. Yes, sir.
Okay. So basically we have 0 to 1 interval. Number 2. So it is 0, 1 by 4, 1 by 2, 3 by 4 and 1. So the formula will be just 1 upon 4 f of 0 plus 2 times f of 1 by 4 plus 2 times f of 1 by 2 plus 2 times f of 3 by 4 plus f of 1 is equal to 1.75, right? By 4 1 plus f of 0.25 is alpha 4 alpha plus 8 is equal to 7. You are getting 1.125 something. Am I making any mistake here?
Sir, in the
Okay, it
formula
will
it
be
is
1 by
h
2
by 2
also.
now. Yeah.
It will be this. So 14, right? 4 alpha is equal to 6. Alpha is equal to 1.5, right?
Yes, sir.
But still you were getting something else.
Yes, sir. I forgot to multiply by 1 by 4.
Okay. So is it good now? Do try question number 3. Okay, so if you read this, so how will you approach? What will be my trapezoidal rule? It will be 4 equal
2 by 2 into f of
right?
0 plus f of 2 plus 2 into f of 1.
Plus 2 into f of 1. Why do you need this term? See, if you want to apply this, you don't have to go to composite trapezoidal rule, right? Sorry, just one. Because then b minus a upon n. So basically what you are doing here, if this is your interval 0 and 2, you are breaking it here, right? If you are doing such type of stuff. So the length of the subinterval is just 1.
Yes, sir.
So, and they are not asking you to do the composite trapezoidal rule.
Yes, sir.
They are just
Only
asking,
f of 0 plus f of 2.
yes, so 4 is equal to 2 upon 2 f of 0 plus f of 2. This implies f of 0 plus f of 2 is equal to 4, right? This is one equation. Now, from Simpson rule, it will be 2 equal
2 by 3.
2 upon 6.
Yes, sir. F of 0 plus f of 1, f of 2 plus 4 into f of 1.
Right. Is it clear why it is 2 by 6? Because in the formula, if you see it, it is nothing but
H
delta
by
x by
3.
3. But delta x here, when you are dealing in Simpson rule, so basically if this is your interval 0 comma 2, so you break it here to get 3 points. Simpson rule is exact for polynomial of degree 2, right?
Yes, sir.
And not only 2, it is also exact for polynomial of degree 3 also. But when we derive the formula, we take a polynomial of degree 2. Okay. So when we take a polynomial of degree 2, we need in each interval we need at least 3 points. So basically the length of the interval, which is whatever the length of the interval is given to you, you do by 2 there. So that is why it is 2 is equal to length of the interval is 2 minus 0 and then divided by 2 divided by 3 of 0 plus f of 2 plus 4 times f of 1. Is this fine? So
Yes,
basically
sir.
6 is equal to f of 0 plus f of 2 plus 4 times f of 1. This implies f of 1 is nothing but, because it is already equal to 4 by 2. Fine.
Yes, sir.
Okay. Do question number 4.
So C naught equals to 1 by 3, C2 equals to 1 by 3, and C1 equals to 4 by 3.
C naught is equal to 1 upon 3. C1 is equal to
4 by 3.
and C8 is equal to 1 by 3. So it is nothing but just the Simpson rule, right?
Yes.
You might have done the derivation of Simpson rule, nothing else, right?
Yes, sir.
Okay. Do question number 5. Are you aware about the length of the graph of the ellipse? How to find the length of it?
No, sir.
So let me do this. That's x square upon 3 square plus 5 square upon 2 square is equal to 1. So if I compare it with the general equation, my a is nothing but 3 and b is nothing but 2. Okay. So in order to find the length of the ellipse or length of any function, the usual formula is this: 1 plus dy by dx whole square dot d of x. This is the formula which we do, where x ranges from say x naught to x1. Length of some arc y is equal to f of x. If you have given some function in y in terms of x, then length of the function is given by this. But since we are in ellipse, so it is not quite making sense to do this dy by dx, because again it will be in terms of y and x. So we do the change of variable here. We put x is equal to 3 cos theta, y is equal to 2 sin theta. So why am I doing this? It is nothing but something of this sort, right? So 3 comma 0, 0 comma 2, minus 3 comma 0, 0 comma minus 2. So this is my x coordinate. So what we usually do when we are in a circle, circle is a special form of ellipse where x-intercept and y-intercepts are same. So in circle we do the substitution like this: x is equal to r cos theta, y is equal to r sin theta, where r is the radius, right? But since in the ellipse we have x and y intercept different, so what you do, put x is equal to 3 cos theta, the x intercept, y is equal to 2 sin theta, the y intercept. Okay, and this integration will now transform to integration 0 to 2 pi integration x prime theta square plus y prime theta square d theta. Now I think you can solve the integration, because x is x prime is nothing but 3 sin theta, sorry, minus 3 sin theta. So basically you need to solve this integral: 9 sin square theta plus 4 cos square theta d theta, or in particular you need to solve 0 to 2 pi integration 4 plus 5 sin square theta d theta. So basically they're asking you to find the length of this integral. So basically you need to solve this integral. Now you can use any of the method you want.
Okay, sir.
Probably I'm going a little fast today, so is this making sense, or I need to repeat this?
Yes, sir, it's clear. Sir, if we uh, just solve root over of 1 plus dy dx whole square,
No, if
then
you do, just a second. I'm in the middle of a call. Just a second. Yes, please ask now. What was your query?
say if we just solve the root over 1 plus dy dx whole square and then find the integral.
But for that you have to have y to be in terms of x, right? So if I write y to be in terms of x, what
Oh
will be,
yes, yes sir, yes sir. There will be a dy
so
dx term. Yes.
right? Or at least you want this then, either y square term, or if you take it to be y, it will be again plus minus. So for that you will try to cope up like this: y square to be this, and then it will be 2y dy by to be minus 2x upon a square. So dy by dx will be again minus 1 upon a square x upon y. That will surely do. But then again, everything is getting in terms of x and y again. So that is the trouble.
Yes, sir.
Okay. What about question number 6? What do you need to do here? You have say a b f prime a f prime b. From these 4 points, you can get all. Definitely define a cubic Hermite interpolation, right?
Yes, sir.
And then you just need to integrate it. Have you guys done Gauss quadrature stuff in class by now?
Yes, sir. Gaussian quadrature.
Okay. So it because I was not sure whether you have done it till now. Okay, so please tell me whether you want to do question number 6 now only, or you want to try it once.
Sir, I will try it once.
Okay, you can try. If you face any difficulty, you can let me know.
Okay, sir.
Okay, what about question number 7? Okay, you are the only one who's taking the class, is it so?
Yes, sir.
So I think that rest 3 problems are something which should be discussed with all of them, or at least last 2. I was not aware. I didn't see in that file. You are the only one who is taking the class.
Sir, then discuss the rest of the problems in the next class.
Yes, I will discuss the next problem in the next tutorial because I think these might be discussed with all of you.
Yes, sir.
And by the way, Debika, right?
Yes, sir.
So please tell me, since you are the only one. Okay, let me stop recording first of all. Okay, I can't stop it.